So in last class we have seen what guys, diffusion in solids, diffusion in liquids, and as well as diffusion in gases. So Danishka, tell me in diffusion where it is maximum, where it is minimum. Diffusion in
Sir,
gas. Yeah.
lower concentration to higher concentration, sir.
Now I am asking in which we have three states of matter: gases, liquids, and as well as solids. So, in as we already discussed in the last class, diffusion in gases, diffusion in liquids, and as well as diffusion in solids. Now I am asking diffusion rate. Rate of diffusion is maximum in where? Rate of diffusion is maximum in which substances? That is what gases or liquids or solids. Rate of diffusion is minimum in which substances? That is what I want. So maximum in where and minimum in where? Yes, please. Rate of diffusion, maximum where?
Gases, sir.
That is what you see. Dhanishkar is not all saying. Maximum rate of diffusion is maximum in gases. Why? Why Dhanishkar gases it is maximum? Because the particles are freely present. Understanding? So the distance between the intermolecular space is maximum. Means intermolecular force of attraction is minimum. So that they can freely move faster, much faster. So they are having more kinetic energy or less kinetic energy. More kinetic energy, so that they can move much faster. So the diffusion rate is much faster in gases. So next one, second, where the liquids, it will be moderate diffusion. Understanding? It is not neither too or nor low. It will be moderate diffusion. And if it comes to the solids, the diffusion rate is what? Rate of diffusion minimum level. Dhanishkar, you have to speak, Dhanishkar. So rate of diffusion will be in minimum. Why it is minimum? By this time you can understand and you can tell me. So the diffusion rate is minimum because why? Particles are closely packed or loosely packed?
Closely packed.
Closely packed. That I need to expect from others. Only Harish will is there. Any others is not there. So that is what you can see. So in solids, the particles are closely packed so that the intermolecular force of attraction is more and the intermolecular space is very, very less. So that diffusion also what? Diffusion rate of diffusion is very, very less. Now you can see in last class I have given you examples of all the things. Yesterday you not attended, correct, Dhanishkar? Yeah, I understand now. But you have to watch it, correct? You have to complete it, correct? When you will watch? Today you try to finish it, okay? Understand?
Okay, sir.
Now that is, if you'll understand that only, it will be very nice. It is very important concept. Okay, Dhanishkar?
Okay, sir.
Okay, now you can see, for example, as we know yesterday I said, the rate of diffusion means diffusion is increases or decreases by one parameter. What is that parameter, Hari? You can increase the diffusion or decrease the diffusion by one thing. What is that? I already told you in this class. Suppose if you want to dissolve the sugar in water, what are you doing, Dhanishkar? Tell me. Are you simply pouring the sugar and leaving, or you are continuously stirring, or you are shaking, or you are mixing? What are you doing? How the sugar is dissolved in water?
Sir, we are stirring and mixing,
We are
sir.
stirring, or else we are shaking, we are mixing, something we are doing. Yes or no?
Yes, sir.
Same way, if you are heating the substance and if you are trying to dissolve, then much faster the diffusion will be in much faster rate. That is what we studied in the last class. Yes or no, Hari?
Yes, sir.
So when we are heating, that is what? Heating will give you what? Temperature. Do you understand? So the temperature is the main parameter which will decides the rate of diffusion. Are you understanding? So rate of diffusion increases by increasing temperature or decreasing temperature. Rate of diffusion. Rate of diffusion increases by increasing the temperature. Understanding rate of diffusion is decreases by decreasing the temperature. Keep it in mind. If you want to increase the rate of diffusion, so then what we have to do, guys? We have to heat up. We have to increase the temperature, decrease the temperature. Dhanishkar, we have to increase the temperature. Okay. Now, sir, what will happen, sir, when we increase the temperature? For example, if I am continuously pushing you, your speed will increase or not? Suppose you are cycling. Imagine now if I am continuously pushing you, your speed will increase or decreases. That is what I am asking. Yes, everyone. Your speed will increase or decreases. If I am trying to push
Sir,
you,
it will increase, sir.
what will happen? Our speed will keep on increases. Yes or no? So that is the
Yes,
same.
sir.
When the temperature is keep on increases, then what will happen means the particles which are present inside the matter, they will keep on will get the energy. Energy is keep on increase or not? Yes, that
Increase.
energy only we used to call it as kinetic energy. Understand? So the energies keep on increasing. So it will leads to the what? The particles will move more randomly. Understanding? So particles will start moving randomly, so that the diffusion will increase or decreases. Diffusion will
Increases.
increases. So by increasing temperature, we can increase what? Increase the rate of diffusion. Understanding everybody? Vartani, rate of diffusion. That is what we can say. So temperature is the main parameter which will decides the rate of diffusion. Either the diffusion is taking place faster or diffusion is taking place slower will be decided by temperature of the substances. That is what. Now that is why we need to know how to measure this temperature, what is the common unit of this temperature, and what is the SI unit of this temperature. That is all we must know. So you all people know that what is the two units of system we studied in already. That is we studied two system of units in motion chapter physics. What is the two units of system? One is
SIN.
one is CGS unit and another one is what?
SI unit, sir.
Unit. Understand? The same way. What do you mean by CGS unit? Full form, Vartani? CGS unit, at least
Centimeter,
centimeter.
gram second,
Yeah,
sir.
centimeter. Very good, Danishka. Centimeter, gram, second unit. SI unit means what? Standard international unit. Yes or no? So, same
sir.
way you're taking the temperature. Temperature also we should know what is the common unit and what is the SI unit of temperature. Okay, shall we start, guys? Everyone? So that is what. So the common unit of temperature and SI unit of temperature. Let us please all of you keep heading. Common unit of temperature and SI unit of temperature. The common unit of temperature and SI unit of temperature. Shall we start, guys? Everybody?
Yes, sir.
Yeah. So now observe very carefully. We're having so many units for measuring the temperature. If we'll go other countries, different countries having different temperature. So let us make maximum temperature units which we all people knows that. So if we'll take here, Celsius scale of temperature is the measuring temperature in our everyday life. That is why we can say the common unit of measuring temperatures is degree Celsius. What is that, guys? What is the common unit?
Degree Celsius.
Degree Celsius. The common unit is which we are measuring in our daily life. That is what? Degree Celsius. CELSIUS. Understanding? So SIUS. And we are having special scale this. That is what we used to call it as Celsius scale. Understand, Ra? What is that scale we used to call it as? Celsius scale.
Celsius scale.
Celsius scale of temperature we can say. Scale of temperature. So what is the unit of this one? The common unit is degree Celsius. What is our body temperature? Anybody, for example, what is our body temperature? Our average body temperature. You might be studied already. 37 degrees Celsius. What is that? Our body temperature? 37 degrees Celsius. Understand, everybody? That is what you have to remember. So the common unit is, you can notice it, that is what degree Celsius we can say. Now, all of you, do you have phone, guys? You are having phone, Harish, Gokul, Minister. Now your phone, it is showing
Sir.
it is showing the room temperature. How much it is showing? Tell me, everyone. What is your room temperature presently? Your phone is showing. I want to know. Everyone, tell me. It will show you on the screen. Today is Wednesday, 18th May. Now it is little cloudy in nature, and my phone it is showing the temperature is atmospheric temperature, Wednesday today. Understand? So Wednesday, so 18th May, my phone is showing it is little cloudy in nature and it is showing 27 degrees Celsius. Is it right or wrong? Your phone, you just verify and tell me.
Here also same, sir.
Yeah.
Partly cloudy and 27 degrees Celsius.
Yeah, degree Celsius. So why it is showing degree Celsius? Because what? This is the most common unit of temperature. Understand, Danishka, Gokul? So that is the reason why it is showing 27 degrees Celsius. What is in our area? What is the temperature? In our phone you can see. You can tell me. Yes, please. It will be like that. So that is what degree Celsius is the common unit, most common unit of temperature. So how we can represent degree Celsius? We have to write capital C, understand? And this side, left side numerator up, understanding? Subscript, superscript, we have to keep small 0. So that is the symbol of degree Celsius. We'll read as, how we can read, guys? Vartini, how we can read? Degree Celsius, understanding degree Celsius we can say. So the laboratory thermometers which we will use it for performing the science experiments, all they are called as, they will be noted, will be calibrated in degree Celsius only. Do you understanding? So that is what you have to remember. So lower classes you might be studied the thermometers. Thermometers, what is the use of thermometers, guys? Anyone? Thermometers. Thermometers, 6th class you will get it. Thermometers. What is the use of thermometer? It will measure temperature. Is it yes or no? Measure temperature.
Sure.
Okay. So now these thermometers are two types. One is for science experiment. Another one is for clinical experiment. Clinical means what? Clinical thermometer. Clinical thermometer for our body temperature, measuring body temperature and all. Next one is called as laboratory thermometer. Understanding? So laboratory thermometer, we will measure in how, guys? Clinical thermometer and as well as laboratory thermometer. So clinical thermometer we can use in clinic, means medical purposes, medical use. And laboratory thermometer we can use for scientific experiments. Do you understand, Hari?
Yes, sir.
Okay. Now these laboratory thermometer, basically it will be calibrated in how, guys? In lab. Basically it will be calibrated in, calibrated means measurement. Calibrated in which degrees, which units? Degree Celsius.
Celsius.
Understand? That is what you have to remember. And if you'll notice it here, the starting point of, I will say you that everything. So the calibrated on which scale of temperature? Degree Celsius scale of temperature. Is it okay, everyone? Yes or no? Please respond. And if it comes to the
Yes, sir. Yes, sir.
clinical thermometer, medical purpose, basically it will be, some clinical thermometers will be in degree Celsius, or some will be, or we can use degree Fahrenheit. What is this one? Degree Fahrenheit. Understanding? So Fahrenheit, H-E-I-T. Those degree Fahrenheit. So the scale here, which scale will use? Fahrenheit scale. Is it okay, everyone? Yes, please respond. Yeah, that is what. Understand, everybody?
Yes, sir.
Yeah.
Yes, sir.
That is what everyone should remember. So degree Fahrenheit, F-A-H-R-E-N, F-A-H-R-E-N, H-E-I-T, Fahrenheit. Okay. So this is what scale we can say, Fahrenheit scale, F-A-H-R-E-N, H-E-I-T, Fahrenheit scale of temperatures. Okay. Now, but this is all we used to say general units only. This is Fahrenheit also, degree Fahrenheit also general. What is our body temperature in degree Fahrenheit? If you go to hospital, they will say body temperature. Danishkar may be know very well. Reddy also, Hari also, you can see Gokul also. Anyone? What is that? Anybody? Yes, please.
Sir, 98, 99 degree Fahrenheit.
98.4 degree Fahrenheit. Understand? This is what our body temperature, which is equals to how many degrees Celsius? Which is equals to how many degrees Celsius? Just now I said. That is what?
37 degrees.
37 degrees Celsius. This is what our healthy body temperature. Okay. So that is what you have to remember. So this is what, how the common we can measure. What is the common scale of temperatures, everyone? What is the common scale of temperatures? That is what? Degree
Degree
Celsius and as well as degree Fahrenheit. Is it okay, everyone? Please respond.
Yes, sir.
Okay.
Yes, sir.
After, let us finish this two first. Then you can see the SI unit. SI unit is very, very important one. So notice it. The another scale of temperature, which we used to call as Kelvin scale
Kelvin.
of temperature. What is that?
Kelvin.
Kelvin scale of temperature.
Kelvin scale of temperature. So this is what internationally accepted temperature. So what is the SI unit of Kelvin temperature? By this time you might be understand. The SI unit of temperature is degree Kelvin, but Kelvin we will write only with the capital K. No zero up. Is it okay, Danishka? No zero is presented. Understand? So we'll present the SI unit of measuring temperature is Kelvin. No degree is present. Understand, guys? Please respond. No degree means no zero is present at the superscript. That is what the SI unit. What is the SI unit of temperature, everybody? What is the SI unit of temperature? It is,
Kelvin, sir.
what is that? Kelvin. And what
Kelvin.
symbol? What is symbol? Capital K
Capital K.
Capital K.
is the symbol. Okay. Now it is what? What is the SI unit? Now you can see we need to know what is the conversion between degree Celsius and degree temperature, degree Fahrenheit, and same way degree Kelvin. Yes or no, guys? Yes, ready?
Yes, sir.
Yeah, because Harish, because you can see as we know, one meter is equals to how many centimeters? 100 centimeters. Same way, 1 centimeter equals to how many millimeters? 10 millimeters. Understand? Same way, 1 kilometer is equals to how many meters, Gokul? We know that 1000 meters. Yes, sir?
1000 meters, sir.
Same way, this is what we used to call as unit conversions. Yes or no, guys? Unit conversions. Okay. Now, as we know, what is the SI unit of length? What is the SI unit of length? Meters. Yes or no? And what is the CGS unit of length? Centimeters. So we have a conversion between meters and centimeters, and same way centimeters and meters. Is it okay, Tanishka? Respond, yeah. Now, similar way, we must know, understanding Kelvin scale and as well as Celsius scale and as well as Fahrenheit scale. Now, for your purpose, I am teaching you one more scale also. That is also very, very important scale. The fourth kind of scale of temperature. That is what, remember, Hari, very carefully. Rankine scale. What is that scale? Rankine scale of temperature. Is it okay, everyone? Please respond, all of you.
Yes, sir.
Yes,
You
sir.
will notice it here. Totally, I taught you now 4 different scales. What is the 4 different scales, everyone? What is the 4 different scales? One is degree Celsius. Try to speak, yeah. One is degree Celsius. Next one is what?
Degree Fahrenheit,
Degree Fahrenheit. Next one is
Kelvin, and Rankine.
Kelvin.
Rankine scale. Yes or no? Now, let us take, understand, everybody, observe very carefully. Oh, 1 minute. Let us be. Now, totally we are having how many scales, guys? 4 scales. Yes or no? Now, let us discuss the relations. Like as we studied, 1 meter is equals to how many centimeters, Danishka? 1 meter is equals to how many
100
centimeters?
centimeters.
100 centimeters. Same way, we should know 1 degree Celsius is equals to how many kelvins. Yes or no, guys? Please respond. Same way,
Yes, sir.
like we have to convert it to degree Celsius to degree Fahrenheit to understanding Kelvin, Kelvin to again degree Celsius. That is all we have to know it. You have to know. You are interested or not? Shall we study now?
Yes,
Yes,
sir.
sir.
That is what. So observe very carefully. This is what the 4 scales I kept here. So hope you all can understand. So this is the 4 scales I kept. First scale is what? By this time you have to say. First scale is what?
Degree Celsius.
Scale. Understand? So we'll measure in how? Centigrade. Understanding? So this is the first one is Celsius scale. Is it okay? Now, next one is what, guys? Let me take now Kelvin scale.
Kelvin.
More important because this is the common unit, or we can say CGS unit, and this is called as what is unit? SI unit. Okay, main units. Next, Fahrenheit. So Fahrenheit is okay. That is also very important. So now last one is what, guys? Last one is what? Rankine scale. Okay, so that is what. Now observe very carefully. 1 meter is equals to how many centimeters, guys? 1 meter is
100
equals to how many centimeters? We know that 100 centimeters. Similar way, you can notice it. Remember, the laboratory thermometer degree Celsius will start from 0. Where it will start from, guys? It will start from 0 degrees Celsius and will end from 100 degrees Celsius. What is that? 100 degrees Celsius. Okay, everybody. So Celsius scale, where it will start? What is the starting point of Celsius scale?
0.
0. And what is the maximum one? 100 degrees.
100.
Understand? Same way, if you'll notice it, understanding, Kelvin scale will start from, understand, 273. Kelvin scale will start from 273, ends with 373. Is it okay? So why it is I am saying, I will let you know you. Okay, don't worry. Now if you'll notice it very carefully. So as we all know that, let us discuss very careful, observe very carefully. Now 273 is over. Now that is what I'm saying. This value is also here. You don't note it down. Let us discuss now. If you'll notice it very carefully. So as I told you, degree Celsius will start from where, guys? Celsius scale will start from where? Celsius scale will start from? Celsius scale will start from where?
0.
0 degrees. Understanding? 0 degrees Celsius or 2. It will be varies where? Till 100 degrees Celsius. Okay. So that is what the range of Celsius scale. Okay, everyone. Same way, it will take Fahrenheit scale. Understanding? So FAHRENHEIT Fahrenheit scale it will take. So the starting point of Fahrenheit scale is, shall I say, everyone? The Fahrenheit,
Yes, sir.
which is minus 459 degree Fahrenheit, and it will be ends with a 212 degree Fahrenheit. Is it okay? Understand, everybody?
Yes, sir.
Yes. So that is
Yes, sir.
what. Next, you will take same way. Observe very careful. Next one, Rankine, Kelvin scale. So Kelvin scale, as I told you. So Kelvin scale, it will start from 273 and it will ends from, understanding where? 373. Okay. So more than that also we can take it. Is it okay, Harish? Nothing problem. Understand? That is what. Now, if we'll take next Rankine scale, understanding? So Rankine scale, if you'll notice it, so here also the same thing, which is happening, like a 4 it will be there. So this Rankine scale will start from 0. Okay. So Rankine scale starts from 0 and ends with 672. How much? 672. Understand? So this is what the range of what is this? Degree Celsius, Fahrenheit scale, and Kelvin scale and Rankine scale. Okay. Now Kelvin scale, I did mistake. It's not from 273. It will start from 0. Where it will start, guys? It will start from
0.
So that is what. Please all of you modify. So it will start from 0 and it will be ends with what, guys? It will ends with a
370.
degree, 0, and it will ends with a 373 kelvins. Okay, so this is what it is. Now we all know that, you all people know very well. So converting solid into liquid, what we used to call, lower classes also we are studying. Converting solid into liquid, we used to call it as something. What is that? Converting solid into liquid, we used to call it as melting. What we used to call? Melting.
Melting.
We are converting liquid into gas. What we used to call, guys? Boiling. Understanding? So that is what. So now if you take for example, what is the melting point of ice? Melting point, where the temperature, when the ice will converting into liquid, that is what the temperature we used to call as melting point. Understanding? So if we take melting point of ice is 0 degrees Celsius. How much, guys?
0 degree.
Degrees Celsius. Same way, if you want to make the boiling water, boiling point of water, if you take, means converting into water vapor, then boiling point of water is 100 degrees Celsius. How much, guys?
100 degrees Celsius.
How much it is? 100 degrees Celsius. Understanding? That is what melting point and boiling point of water. Is it okay, Hari? Yes. So we will study that one in this chapter, but what I want to say here is we have so many different substances. So every substance is having separate melting point and as well as separate boiling point. Is it okay, guys? Separate melting point
Yes,
and
sir.
separate boiling point. So every substance, suppose if you take iron, if you want to melt it, is it possible to melt by using 0 degrees Celsius?
No, sir.
No, if you have to heat around 1500 degrees Celsius to melt the iron. So what is the melting point of iron? Anyone? What is the melting point of iron?
100 degrees Celsius.
1500 degrees Celsius. That is what we can represent with a MP. MP means melting point. Same way, boiling point, how we can represent? Boiling point will represent with a BP. Is it okay? Melting point and boiling point. So based upon this, we can equate degree Celsius and degree Fahrenheit and all. Understand? Shall we start now? Analyzing, guys? Yes, please respond. So, as we know, water is the most common substance in this earth. Understanding, most common substance. So that is why you might be heard laboratory thermometer. What is the range of laboratory thermometer? As I told you, thermometer, laboratory thermometer. Please respond. Laboratory thermometer. What is the range? 0 degrees to 100 degrees Celsius. Understand? So why it is made 0 to 100 degrees Celsius? Because it is based on water. Understanding? It is designed with the help of melting point of water, ice, and as well as melting point, boiling point of water. Understand, Hari? Gokul?
Yes, sir.
Daniska?
Yes, sir.
That is what. Okay. Now you can see. Let us take. I will take the substance. This is what I'm saying. So as I told you. So we all people know that what is the water melting point? Just now I said. What is the melting point of water? Everyone. Yes, please respond. What is the melting point of water? Melting point of water is how much, guys?
0.
0 degrees Celsius. Now, if we'll take same way, if we'll convert it into degree Kelvin, sorry, not degree Kelvin, Kelvin. So, the melting point of water is 0 degrees Celsius. Now, in Kelvin scale, if we'll come, it is equals to 273 Kelvin. How many Kelvins, guys? 273 Kelvin. Understanding? So from that I can come to one relation. First relation. What is the first relation? 0 degrees Celsius is equals to how many Kelvins, guys? 0 degrees Celsius. 0 degrees Celsius, which is equals to how many Kelvins? Please speak. 273 Kelvin. Understand, everyone? Yes, please respond.
Yes, sir.
Now,
Yes, sir.
0 degrees Celsius equals to how many Kelvins? 273 Kelvin. Understanding? So that is what you have to remember. So now next, let us take next one. So same way, if you are by the time if you are measuring in Fahrenheit scale, then 0 degrees Celsius is equals to, remember, 32 Fahrenheit. How many Fahrenheit, guys? 32 Fahrenheit. So I can say 0 degrees Celsius is equals to how many Fahrenheit? 0 degrees Celsius is equals to 32 Fahrenheit, degree Fahrenheit. Same way, 32 degree Fahrenheit is equals to how many Kelvins? Hari, which is equals to 273 Kelvin. Understand? Equal or not? Yes or no? Please respond. Yes? In mathematics, A is equals to B, B is equals to C. Then what will become? A is equals to C. Yes or no? So that is what? The similar way. So degree Celsius is equals to 273 Kelvin. So degree Celsius equals to 32 Fahrenheit. Same way, Rankine scale. Rankine scale if will come, which is equals to 492. What is the Rankine scale value, guys? 492. Understanding, all of you? Please respond. 492 Rankine, capital R is the symbol. Rankine scale, capital R. So this is what, guys? This is the melting point of ice. Understanding, everybody? Melting point of ice, or we can say freezing point of water. What is that? Everybody?
Melting point of ice reaching
of
point
water.
of water.
Temperature where the water will become freezes, ice, or same way, ice will converting into water. That is what we can say. So these all are equal or not, Hari? 0 degree Celsius is equals to 273 Kelvin is equals to 32 degree Fahrenheit is equals to 492 Rankine. Is it yes or no? Yes, please respond.
Yes,
Same
sir.
way, this is the
Sir.
melting point of water. What is the boiling point of water? Everybody, what is the boiling point of water? 100 degrees Celsius. Understand? Now here, if you notice it very carefully, 0 become 100. How much it is increased, guys? 0 become 100. How much it is increased? 100. So here also 100 will increase. So 100 will increase means how much it will come?
373.
373. Same way, Rankine scale if will increase, then that is not 100, it is 212 degree Fahrenheit. Next same way, 492, it will become 672 Rankine. How much it is? 672 Rankine. Okay, that formulas, converting formulas is there. So this is what boiling point. What is this point, guys? Boiling point. Understand?
Boiling point.
You tell me, guys, at the 0 scale, as we know that the Celsius scale will start from 0 and 100 degrees. Now, what is the, you tell me, 0 degrees is equals to 273, 100 degrees is equals to 373. But Fahrenheit scale and Rankine scale is not 100 is increased. Do you notice that? Kelvin scale and Celsius scale only 100 is increasing.
200.
100 is increasing. Here also 100 is increasing. Yes or no, guys? Yes or no?
Yes, sir.
That is what. So please all of you remember the most important point in even in engineering level, the same thing will come. That is what, if in Celsius scale, if in degree Celsius, 1 degree Celsius increases, then Kelvin scale also how many Kelvins increases? Then Kelvin scale also how many Kelvins will increase? 1 Kelvin will increase. Do you understand what I'm saying? Yes, please respond all of you. Suppose
Yes, sir.
here temperature will become 0 degrees to 1 degree Celsius. Then what will happen in Kelvin scale? Everyone tell me. Kelvin scale, what will happen? 273 Kelvins will become what? Plus 1. What will happen? It will turns into
272.
Kelvin. Understand? Now, 1 degree Celsius will become 10 degrees Celsius. Here, what will happen? Suppose, let me take 0 degrees Celsius will become 10 degrees Celsius. Then what will happen here, Hari? 273 Kelvin, it will become what? 283.
20.
That's all. Understanding? So, rise in temperature in degree Celsius, which is equals to rise in temperature in degree Kelvin. Kelvin. Is it yes or no, guys? Yes or no?
Yes, sir.
No. If you can increase the temperature
Yes, sir.
in Celsius or you can increase the temperature in Kelvin, both are same or not? Both are same or
Same,
not?
sir.
Now,
Same.
if degree Celsius, temperature is increases from 0 degree Celsius to 100 degree Celsius, then Kelvin scale, what is happening? Dhanishta, 273 Kelvin will becomes what? Plus 100 if you add. What will come?
373.
373 Kelvin. That's all.
373.
That is what you have to remember. Any doubt? Okay. So that is what we are doing. So now, temperature on Kelvin scale, if you take, how much we are adding? Temperature on Kelvin scale, if you take, how much we are adding? Degree Kelvin, we are adding how much, guys?